engineering. Okay, so everything as such. Okay, and again, yeah. So like whatever is the question, please try to mark it in the chat box itself. And again, if really required, yes, definitely, like I'll unmute you, and again, like we can definitely discuss, or otherwise it is going to be a kind of mess for everyone. Okay, so all the best, guys, to learn, have a very good learning today. Fine. So I'll share my screen, and then like I'll start things off from there. Okay. So hope you guys are able to see my screen. Fine.
Yes, sir, it's visible.
Yeah, thanks for that. Okay, so like most of you are here to learn about data engineering, but again, like where exactly this data engineering fits in the entire spectrum of artificial intelligence, I would say. Fine. We talk about artificial intelligence, and under artificial intelligence, you have this data science and data engineering stuff. So basically, like, yeah, so we'll start with the very basic of, okay, what exactly is this data science, and what exactly is this data engineering? Let's understand. So data science is all about like understanding, or that is working with the data, particularly from what do you say, a research point of view. So not from not exactly from production point of view. So to understand this, you need to have a very clear picture of a particular ML flow, or I would say a machine learning flow, a machine learning process flow. Right? So what happens normally in machine learning? So in machine learning is nothing but what is now machine learning at the end of the day? Anyone? Write answer in the chat. What is machine learning? What is machine learning? Anyone, guys? Please type it in the chat. You know it. We're talking about machine learning, right? So you are here to know or understand the application of data science, data engineering and machine learning. What is machine learning? Creating an algorithm, okay, as requirement to run machine itself, okay, fine. So here it's a creating an algorithm or a training a machine. Okay, good. So good participation. Create automated model with data. So it is one of the type of AI, create a model for predictions. Okay, capability of machine to imitate intelligent human behavior, interact and train machines. All these are fine. So very good. So almost everyone of us know one thing or the other. Okay. So particularly if I zero down everything to few categories, yes. One is we talk about automation, right? And another one is, yeah, the machine learns itself. Okay. Machine learns by itself. So this is what we say, right? So, okay. So what is required for a machine to really learn? So you have to start with something called data. So you give data as an input, right, to the model. When we say model, all I'm referring to is a very good algorithm, okay, based on or as per your requirement. Let's say if you're going for like a regression case, a regression business case, or like a classification business case, let's say. So you have to select algorithm based on your use cases. Like maybe like you will go for linear regression algorithm, or SVM algorithm or whatnot. So there are thousands of algorithms nowadays. Again, like you can choose one, and again, like you will get some predictions as output. Right. So here, where exactly the machine learns? See here, just understand the question very clearly. Okay, so you are giving the data, okay, through a model, and the model actually it runs on the data which is being provided to you, provided to it, in fact. Okay, and the model outputs something called predictions. Very good to see that. But here, where exactly the machine learns? Yeah, Sharad Babu, you're here. Good to see you. So where exactly the machine learns? Because we said, okay, automation, to some extent, yeah, I do agree. Okay, so there is some automation. We do something, right? We try to automate with model or without model, whatever, right? So like without model is also possible automation, right? So you can do hard coding. So very much you can do that. Okay. But in case of once you have these predictions, the learning, where exactly the learning happens? The learning doesn't happen directly from the predictions. Let us understand one thing: machine learning works. So those who have already attended, yeah, you know it already, but still. So it's a very good refresher for you. So machine learning works based on examples. Right? Examples. These are nothing but the data what you are giving. The data you are actually what data you are giving for that matter. So you're giving, let's say, a simple data I'm giving, right? A student name, okay, and his marks in mathematics, his marks in science. Right? This is a simple data set. I can have as many data as possible. So I can send it. And I'm not going to do any mathematical calculation of this maths and science, and I'm not going to add or subtract it. Okay, I'm not going to do such manipulations. Okay, such manipulations are not not for what do you call it? So not meant for this data level. Okay, it is meant for your model levels. So your machine actually gets the information, the requisite information or requisite insight only from the examples. When I say the machine, your model only, nothing else. Okay. And it gives predictions. And this is the difference between like hard coding and machine learning. Even in the hard coding, you can get the same output or similar output, if not the same. Okay. So in hard coding also, what happens is like, yes, I can give some data. I can have, let's say, a very good amount of, so good coding, fine, a very efficient code I can have, and then I can get predictions or outputs. But the problem with hard coding is, like in most cases, whenever there is a change, in the situation or the environment, you have to go, or rather you have to change the code manually every time, and it is so rigid, okay, that it will not change very easy. However, in this case of algorithm, the, even if there is a change in example, the algorithm suits itself to the example. And again, like when we say it suits to the example, or it suits to this, it suits to that, or it learns by itself, what it learns is nothing but patterns. Okay, from examples, what exactly this model learns is nothing but the pattern. Okay, the input pattern of the data. And again, from here, the prediction will also actually reflect the same pattern. So if you are going to give right data, if you are going to give a good amount of data with the right pattern, let's say, if you are giving a proper data, then you will get proper output. If you are going to give, like, let's say, some dirty data, in the sense it is not proper and it is like inflated data, or something tampered, some data which is being tampered, and your predictions may not be really accurate, because what you give in, like that is something what you are going to get out. Fine. And hence it all, the prediction accuracy, the prediction quality, it depends on your input only. It doesn't depend upon, like I said, the machine doesn't know whether it is right or wrong. It all it does is it reads the examples, it takes the pattern out of it, and it reproduces the same pattern in the form of predictions. That is all machine learning is all about. Okay, fine. So where exactly data engineering falls into the picture here? Okay, so before that, yes, data science. Yeah, there was a question on data science. Fine. So what is data science? So all these processes, whatever we have discussed, like data to model to predictions, this is something what we do in data science as well. Once I get the best of the data, like the cleaned data, fine. So which can be used as input, I can take it to the model and I can get the predictions. That's beautiful to have. Okay. So again, like yeah. So if I have to create a new model, let's say, so I don't. The current algorithms are not working, and again I want to create a new algorithm. Fine, then yes, a data scientist is required. So data scientists, is, as the name says, like, yeah, they are typically scientists like who will be working more on the research part of it. Okay. So where exactly the data engineering happens? Where exactly the data engineering happens, in fact. In creative design, okay? Collecting and storing data, okay? That's good. Anyone else? To provide clean data. Harsh Gupta, yeah. Okay. So that's a motive of data engineering. That's a objective of data engineering at the end of the day. And of course, yes, there are many complex objectives also. So one of the objectives is to give proper clean data. Data and modifications, processed data, okay, collecting pre-processing of data, okay, modification of data to form which model can learn, okay, fair enough. So one good thing is, yes, like every one of us, they're really anchored to the very word data. So that's good. Now, okay, now that you understood the ML flow model, let us understand the data engineering part. Okay. So I'm going to erase this and we'll discuss from data engineering part. For that purpose, you need to know something called data abstractions, like what exactly this data is all about, the very word data is all about. Just a moment, if there are any questions. Use of data engineering, Ashutosh. Okay, fine. So maybe so use of data engineering. Why we are going to what is the exact use of data engineering? Yes, you will get to know that maybe in the next 10 to 15 minutes time. Okay. So just please wait, and then yes, like if you do not understand, please to ask me to repeat. Definitely, I will do that for you. So that being said, what is data? Like now that we know the ML flow, what is data? Let's say there is a participant by name Ashutosh. Okay. So what exactly this name signifies? This is a data. This is a data record, I would say, right? So what exactly this name signifies? Ashutosh. This gives us like what insights you could get out of this. What insights you could get out of this very word Ashutosh. Yeah, data is a collection of information. That is fine. But let's say I have a data in front of me, a name. Okay. Okay, or good learner's name, which is Ashutosh here. Now tell me, with this particular name, what and all are the information that I could get? I'm not doing any manipulation, right? Any data manipulation I'm not doing over here. I'm not doing some addition, subtraction. I'm not using any cloud services, or I'm not using any, so like open source softwares. Without not doing, even without doing, not doing any of this, right? So I can still get some insights from this particular thing. Yeah, very good, very good, very good, Anurag. So the first and foremost is like, yes, it is like there is a high probability that this name in India, it is being used for a male child, right? A male for them. Okay. And the next one is obviously, so what other description about the name? Okay. So male, and again, like, yes, you can even get some idea about the religion, fine, with the name itself. And yes, like almost you can get an idea about the location. Location in the sense, not the exact one, maybe like in which part of India, let's say southern part or northern part, or like the east or west. So like, so you can at least say, okay, this is not like normally people in Tamil Nadu, they may not really, they are not going to use this name very often. Okay. So this name is very famous, let's say in Maharashtra, okay, for example, fine. So you can even predict that. So this data actually hides so many information. Okay. And if he is going to give his family name also, that gives even more information. So data is not just a number or text, it is an abstraction layer. Let us understand that this is an abstraction layer. Okay, so more like, in Python, so you'll be saying, okay, so like I can create a list of numbers. So range is 100, which means I can create a list with 0 to 99 easily, right? So this list, I'm just using list. I'm not like defining list, what is list and how many elements and how to take it and how many bytes or bits, all these things like, so we are not taking, right? So we are not doing any of this. So it is abstraction. All this information are already contained in this very word list, and hence we call this as keyword, right? So there are always like, most of the times you must have encode something called keyword error, because you might be using a wrong keyword. Okay. Similarly, as much as the list, like it encompasses many moving factors which are not visible to us, data also encompasses a lot of information, as much as like the name Ashutosh like, encompasses. Yeah, so these are few clearly visible or obvious insights. But again, beyond that, if we dig deeper with a bit more information or a bit more data, obviously we'll get even more information. Clear? So it is an abstraction layer. Data is nothing but an abstraction. Okay, so where exactly the data engineering fits, or what data engineering does with this data? Normally, when we have an Excel sheet, okay, so in Excel sheet, how many rows or columns of data I can have? Just like a approximate, let's say. How many rows and columns of data I can have in Excel sheet? Unlimited, 10,000. 10,000 columns. Okay, so 10,000 approx. So 10,000 approx, I would say like, yeah. So you can have, say, 10,000 rows of data. Okay, let's say like 100 to 150 columns of data. Let's say with the 10,000 rows of data, okay, what is the population of India? A simple question. What is the population of India? Just an approximate answer, let's say. Any approximate answers? What is the population? Yeah, good. Almost. Yeah, that's nice. 130 crores. That's nice. Not 130 billion. Okay. So it is 130 or 135 crores. I will take it as 130 crores as such. So let's say I don't want to do anything, but just want to record everyone's name. Can I do that in Excel sheet? Recording all this data in Excel sheet? Only the name, nothing else, even date, no date of birth, nothing. Right? Can I do that in Excel sheet in such a way that my system doesn't crash? Okay. So every data should have its unique row. We can't. 130, that is 130 crore data in Excel sheet, right? So Excel will die by itself. It will have its natural death. Okay. And again, like your system, okay, like, only God saved, right? So what has to be done? Then we need a better like application, right? So this is an application. Excel is an application. I need better application. Better application in the sense, so we talk about, so since this is 1 crore, we talk about something called big data. So when we get into the data engineering, you require data engineering only when you are going to have a large amount of data, large amounts of data. Yes, there is another factor also which decides the requirement of data engineering. However, if we have large amounts of data, obviously you need to go with data engineering. There is no other principle or no other philosophy that you could really use. So in case of big data, obviously you don't have any mechanism to actually take it to the algorithm level and then get the answers out. That's not possible. Okay. Now, yes, so everything starts with big data. Now again, like whatever in machine learning flow, whatever we have seen to start with, it comes only after this data engineering. This data engineering. And at the start of this data engineering, at the start of any project for that matter, but in this case, I'm like restricting my discussion only to data engineering as such. At the beginning of this gate, what you have is big data. Okay. So what is the tool to store big data? Let's say this 130 crore data, where I can store. Where do you think I can store this 130 crore data? What is the application? Cloud, yeah, very good. So that's fine. What is the application? There is a name for it. Yeah, Siddharth, you are right. So yeah, Vignesh, you are also right. So Hadoop. Okay. So yeah, Hadoop is one application, right, where you can really store your data. So what normally happens is once I store this data, say 130 crore, I'll take only the population data, nothing else. From 130 crore data, we are going to go ahead and we are going to work as per our as per our objective or mission, whatever we want to find. Okay. So that being said, from Hadoop, I have to take this to the model or algorithm. How can I do that? So, and again, let's say someone can say that, yeah, I can take this data to the cloud, right? From the cloud, I can take, let's say after all manipulations, I can take to the model or algorithm. And again, I can get predictions over here. Okay. So this is good. This is a simple flow, okay, or I would say a very superficial flow, which you need to understand. Yeah, AWS is one service, and there are several such services which can be used. Okay, it's a cloud service. Now, big data, Hadoop, and from there, like I take it to the cloud, and again, like I take it to the model, and from the model, I get the predictions. That's really good. Now, is it possible for me to dump all my data into the cloud just like that? In the sense, in this particular example, we are talking about not 10 lakh or 20 lakh or not even 1 or 2 crore data. All we are talking about is almost 130 crore data. Is it possible? Is it possible to really take it directly from Hadoop to cloud? Do you think it's possible? Again, we have a constraint here. It's very tough, right? So it's definitely tough. So it is like, okay, you just imagine, fine, like forget about this data engineering or Hadoop or like Excel sheet or whatever. Let's say I have to write the name of people in paper, in a piece of paper, all 130 crore name. Okay, let's say it's going to take some thousands of books really to get all this 130 crore name. Now just imagine, how can you shift these notes or books from one place to another? Let's say like this is going to take some 1000 or 2000 notebooks. Okay. So you may require some transportation system, right? So like 1000 or 2000, I cannot carry in my car or like a bike, and then like I deliver to the, or rather like I take it to the location where it has to be delivered. All I need is a better and bigger transportation system of this particular data, right? The same thing happens over here. This 130 crore data, right? This has to be broken into chunks, different small chunks, chunks of let's say 100 MB data. So 130 crore data, I'm assuming like this will take at least 50 crore or like not 50, so anywhere closer to 500 GB of data. So I break this into 100 MB data, small chunks of 100 MB. And once I get this, like, yeah, this 100 crore will first go get into the cloud, and then the next 100 crore or 100 MB it will follow. So that is how you load cloud with data. And but this is not all about data engineering. Data engineering is like, this is just the beginning or just the surface of data engineering. So you need to dig a bit more deeper. Now I will stop here for a while to take questions. If you have like an understood, it's good for me and to you also. And again, like if you haven't understood, please do let me know where do you require more clarification. I would be happy to give you that clarification. Yeah. So open to questions. You can paste your, that is, type your questions in chat. I hope you understood up to here. Big data versus the data limits. Okay. So please be very specific about your questions. Fine. Like that will help me to understand it very clear. So Melvin, you understood? Okay. Good. Nice, nice English. So here in this case, we have like, so in essence, data engineering is all about handling huge volumes of data. Right? And again, like processing it and getting it to the model. Right? So it doesn't like, okay, taking to the model and again, like predictions, that is not part of your data engineering. It is not worried about this. Right? So like slowly, there is an overlap of data science and data engineering, that few of the processes in data science, so that is becoming part of data engineering also. However, so let us be very strict up to here, up to taking it to the model or up to just before the model, like where the data has to be in vector form. So we are definitely doing data engineering. Okay, now, yeah, there is a question from Ajit. We compress the data, will the data be lost? Normally an image or video in quality be lost. What about text data? Can we able to compress text data? Okay, good. So like, you definitely, let's say like you are having 10 Excel files or 20 Excel files, and it adds up to around some 200 MB of data, and you are going to compress it. Right? And if you are going to take it like to some other folder or some other system, if you are going to extract it, have you ever seen that particular data getting, let's say, lost? I don't think so. Right? I haven't experienced such a situation where compression actually like brings loss of quality. In the sense, loss of quality in the sense, yes, I have video, I have audio, like, I can have a mid-size or very good resolution and everything is fine. When I say compressing should happen depending upon like, let's say the display, right? Depending upon the display, since you have asked for image or video, so I will use the term display, okay, or the output device, right? If the output device is constrained by its memory size, then compression has to be lesser. That it has to be compressed so that the quality is lesser. Or otherwise, if you decompress, then obviously, like, the data is not going to lose its like quality as such. Okay, so there is a question from Melvin. Data science is different from big data. Data science is obviously different from big data or small data, whatever it is. Because data science is all about results. Like the moment you say like a data scientist, if you're going to like mention the very term or very phrase data scientist in your resume, what you're telling the world is you are a researcher. Okay, you are a scientist. Okay, which means you are going to use several mathematical principles to arrive at different algorithms, to arrive at different kind of manipulations, right? To get the data into the system and get the output. You are all worried about the kind of predictions and the accuracy of the predictions, the errors, what you would be like, what do you call, like, what will be encountering while you are getting the predictions and then reducing the errors, all those things. Okay. Right. So data science, is it different from big data? Yes, definitely it's different from big data. Big data, see, big data is one single concept, and data science is like it's a very it is very academic in nature, in the sense like it's more research oriented. Fine. Ashutosh, yeah, sir, is in the data engineering store, big data. Okay, in big data, we start with big data. That's what I said. So when the data engineering, see if I'm having only 1,000 rows of data in Excel, let's say, or 100 rows of data, I don't require any data engineering. Even a simple pandas will do the entire work. However, hardly any time in production you will see so much smaller data. So like every day, like we talk about some 5 exabytes. If I'm right, like 2.5 exabytes of data, right? So like being produced, right? So on everyday basis, and again this kind of data explosion. So you will be dealing with hundreds of GBs of data at any given day in production. Fair enough. The hope I have answered you. And, what is the prime objective of data engineering? Okay, very good. So the prime objective of data engineering is to ensure you get the right data ready for machine learning model. Fine. Because as I said, let's say if I'm going to have 100 rows of data, I cannot just like that, insert it into the model and get the answer. So it has to be processed. It has to be like a process based on the constraints, right? And then from there on, I have to take the data, right? Or what we call the manipulated data or the clean data, I have to take it to the model to get my final output. Okay. And Siddharth, how important is data engineering and data science field, which is more in demand, data analysis, etc. See, difference between all this, it is fading with time. Okay. And yes, if you're on whatever the field you are going to take, data analyst or data scientist or data engineer, okay, be really strong in it. Be an expert in it. If you're not going to be an expert in it, like none of the field will really help you, because this is a very fast moving field. And again, like the data field last year is not the data field today is not same as that of last year. And data field like 1 year from here will be entirely different from what we are seeing. And hence knowledge in all these 3 areas are really important, because you never know where you will where your interest will shift with change in technologies. Okay. And hence, like if you are going to ask which is more in demand, data analyst, data scientist, or data engineer, I would say all. Okay. So data engineer actually it scores a bit more higher, okay, just a bit more higher. However, all these three, there is very good demand in it. Okay, only thing is, you need to be almost an expert in chosen libraries at least, if not more. Okay, Shantanu Banerjee, sorry for misspelling your name, mispronounce your name, sorry. Fine. Shantanu Banerjee. I was weak in mathematics in school. Okay, I carry 8 years of experience in finance sector. Very good. Not sure if I transfer to data science career and face difficulty in real world scenario. See, since you have been in you are weak in mathematics and you are in finance sector. Okay. I hope like you have overcome the weakness by choosing to be in finance sector. Okay. So if that is true, so you will have a wonderful career in data science. Right. So you need not really worry about that. And again, like finance people, they do really well in data science because there are a lot of numbers involved. Yes, some mathematics definitely So whether you are from science background or non-science background, you really need to have a good grasp of mathematics. Okay. So particularly matrices and calculus. So Ajit, as a data science student, it is compulsory to learn software engineering. Okay, so I will tell you this. Software engineering people are learning data science now. Okay, which means so like they are going to pose threat to you, and hence obviously or I would say so the threat part is from lighter note. Okay, and so do not really be too serious about it. However, software engineering. So yes, you need to know a bit of it, because only stuff is like you are working rather you are doing all these manipulations, these predictions and algorithms or whatnot, particularly using cloud or local systems. and you got to use Shell, you got to use Python, you got to use like Kafka, PySpark, and again different open source packages. And hence, at least a reasonable level of I won't really look for an expert level, okay, in software engineering, but a reasonable level you should have. When I say reasonable level of experience or hands-on, I mean, like, let's say in Python, if you are good in list and dictionary, that's good. Okay, but again, whether you are good in list or dictionary, that will be tested with the different kinds of situation that you get exposed. So be reasonable, be a reasonable developer, be a reasonable Python programmer. That's more than enough to really, come out in a colorful manner, particularly in data science. So, okay, what application mainly involves big data? Almost anything what you're seeing today, so you have this Alexa, you have this Siri, everything's big data. And again, like whatever you speak, like whatever so we do, what we are doing now. So this is again like big data. This is generating so much of data, right? So can we really feel any latency, any lag? I don't think so. This is again big data. So this is happening in real-time basis. And again, your WhatsApp, it's again big data. Your YouTube comments, it's a big data, right? So every application, or I would say like there is no application without big data today or without data engineering, right? Good. That was the next question. Is there any benchmark to call the data into big data? Sorry, I do not get the question clearly. When you say benchmark, what exactly you mean, Yuvraj? So I would be happy if you could elaborate on that. And yeah, Anuradha, feature engineering is a part of data engineering or data science. Yeah, this is one particular topic, which is like it's an overlapping topic. Okay, so yeah, so there are a few aspects of data science also and data engineering also. However, predominantly data engineering. Okay. So what application technology? Yeah, technologies we will speak. Okay, applications, yes. When you say application, if you are going to I understood correctly, like you are talking about the final product, then yes, as I already answered, so you have almost every product which is using big data. Okay. Technologies, yes, cloud technologies, fine, like which is supported by different open source libraries. Which is the best career to choose ML or data scientist? It's like at any day, see, data science, data engineering, data analysis, everything is part of ML. So this is like, if you're going to get confused, yeah, most of the times I do get such questions, but let us understand only one thing. It's like asking whether I should go to school today, or let's say you're studying in class 10, let's say, for example. Okay. So if you're going to ask whether I should go to school today or whether I should go to class 10 classroom as such, right? So again, so hope this particular analogy gives you a clear understanding of what is ML and data scientist. Data scientist is just part of ML, in fact. Okay, tomorrow it may change, but ML as well, like ML is a very big spectrum, okay, an ecosystem, in fact, fine. So and hence, like yeah, so whatever you are learning, data analysis, like if you are a data analyst or data engineer or data science, you're already part of ML. Okay. So there is no not much of distinction, or I would even say like ML is like a way that is it encompasses this. Generally, what a data engineer do should be collect data, do some modification, bring valuable data. Okay, so nobody brings valuable data. Let us understand that. Okay, what a data engineer do? Yeah, data engineer does like yeah, we have seen here, right? So big data to cloud and cloud to model, and it's not really easy. Let me tell you, like maybe like yeah. So I have shown you very easy in the most easiest possible manner. Like here, let's say I have 500 GB of data, break it into 100 MB. No, it will not happen so easily. There are pipelines, there are parallelism. Okay, there are different operating systems. Sorry, open source programs, so which are being used. Fine. So that I'll explain after this session of taking the questions. Fine. So, what applications technologies mainly? Okay, I think we have answered that. Can say difference between ETL and data pipeline. Okay, good. So Data pipeline is just part of it. So ETL is different in the sense ETL is again a concept, a philosophy, and data pipeline is part of that. That is all like you need to understand. For DS, which field is necessary to be known? Okay, so like you can keep counting mathematics, a bit of software, and again a lot of data, and yeah, so a good eye for intuition, some business case, and some business experience. I would say everything around. Okay. However, to start a career in data science, just be strong in the technical skills and or I would say mathematical skills, mathematics and libraries. That is how you start in data science. But the more you use your skill set to get the predictions out, so what you are going to get is very good business insight or business sense behind each and every data point. Okay. D, which field is necessary to be known? For D, okay. For D, yeah, I'll come back to that, right? Because after this, I will definitely get that. For a fresher, how much is the data science field open? Wide open, sir. Wide open, Siddharth. Okay. Fine. Very, very much open. So if you are a fresher and if you have some reasonable knowledge in data science, so take it from me, you will get placed. And yeah, Arvind, I'm from non-CS and I have zero coding knowledge. Don't worry. I have already gone through going through ML classes, but feeling difficult to cope up. Any better way to practice or any suggestions which can help? There's no better way rather than really hard. Okay, so it's again going back to the old school days. So you need to put out at least 5 to 6 hours per day. Right? So to go on high intensity training, kind of so particularly wherever I hope yes. So definitely from Python point of view, hope this question is from Python point of view since you have mentioned you have zero coding knowledge, which means all you need to do is you need to really toil for at least a month. Okay. So in Python, and after a month, you definitely will feel proud of yourself for having put that much of effort and energy. Okay. Because definitely you will be a much better programmer after a month of practice. Okay. So there is no other shortcut. Definitely, that's no other shortcut. And yeah, so to those who do not know me, yes, I do see many people who have already attended my sessions, situations. And yes, those who do not know me, I'm also from a non-CS background. So of course, yeah, 18 years back, I'm fine. So I really did well in my domain. So what we call I want setup, both from software and non-software stuff. And again, yes, in software, as such, I do a lot of learning projects for the past 10 years, particularly from data science perspective. Right? And with that experience, I do say, if you are non-CS, if you are from non-CS background, never worry. So you will be much better than CS background. Also, with the due respect to people from CS background. So yeah, math PG student choosing DS with an E or DS, what field we need to know and how to develop freelancing or how to start up. Okay. So first, I will always suggest, yeah, the days are not when we were starting okay, our career in this particular data science. Now things are very easy for you guys, and hence, do not overcomplicate things by where starting something on your own from the beginning. Okay, so you will be burning your fingers. Okay, and hence, all I would suggest is if you want to do freelancing or if you want to do startup, go join a good company. When I say good company, really good company, fine. So yeah, there are different companies who offer which offers data science and data engineering. However, you need to be really clear which company has scope for more data science projects. Okay. And hence, do join such companies, learn a lot, toil a lot for at least 1 or 2 years, and then and then I need not tell you. So you will be lecturing people on how to do a startup, okay, or freelancing. what future science going develop in this data field? Yeah, the future is bright and obviously like much brighter that you need to run really, really faster. Yeah, so we CSC final year after my education, how to become data engineer. Okay, Rakesh, first do your VCSC very well and concentrate on coding part really well. Be really strong because since you are from CSC, the expectation from CSC background people is very high in the industry, and hence like be a very thorough developer in whatever field you choose, and then like you can definitely like, so think of this data engineering also, so which will definitely come very easy for you guys. So it's there any government job for data analytics? I'm not too sure. Okay, I don't want to comment on that. I'm not too sure. Yes, like if you're going to ask for private ones, yes. So I have facts and figures, but in government I don't have. So what skills we require for data engineering? So we have answered. Cloud is bunch of small data. Even like big data is bunch of small data. That's what we can say. So cloud is has a different purpose and different. Yeah. So we'll finish this remaining part also, and then I will take questions. It will not take too much time. Fine. So here, okay. So I have this big data, and again like cloud, and okay, and then you are moving this to the. So normally, what happens? Like okay, so this part. So let me again discuss in more detail, right? So in place of big data, yes, obviously like you have got Hadoop. However, so not every time you will be like handling big data. So yes, so data quantity is like actually rising, and thanks to the technologies what we have today, okay, particularly from work orchestration to everything. Yeah, sorry. So there is a chat. Okay, fine. So like thanks to the advancement in technologies, particularly in the subscale processes, so we can still use different databases, right? So it goes like this: you go with the database. So what and all is a requisite knowledge what you need to have to be a very good data engineer. So it starts from databases, and you need to have a very good grasp over shell scripts. And we'll see why. Okay. So first I'll give you a layout of what and all you need to know. And then after the shell script, obviously like work orchestration. So work orchestration tools. And go with event streaming platforms. Event streaming platforms. And from there, you take to visualization engine. So between visualization engine need not be part of like data engineering. However, we assume that this ML flow, I'll explain. Let's take a moment. So why I have mentioned visualization engine. So the key part are database, shell scripts, work orchestration tools, and event streaming platforms. So we'll quickly have like a brief about this. The databases, obviously, like, you have SQL databases and NoSQL databases, so which you should be using. Okay. Normally, the open source or the free ones are MySQL, right? And so you'll be using MongoDB, NoSQL. Yeah, so they have a like a lifetime fee. cloud clusters which you can use. So beyond this, when you go to cloud, let's say, so the AWS, Google, Google Cloud GCP, let's say, and the IBM Watson. Right? So these are very famous cloud services, what we have now. So like in Google, you have either BigQuery or Firebase. So BigQuery or Firebase to do data manipulations and data storage as well as manipulations. And in the AWS, you have DynamoDB and IBM Watson, you have DB. So these are the different databases what you have. And yeah, so if your question is, oh, come on, like the database, if I'm going to have 5 different stuff, like yeah, so there are almost some 60 to 70 different databases available in the market, okay, commercial and non-commercial put together. So this itself is overwhelming, right? But it is actually not. Once you learn the SQL part, at least in one of the databases, let's say, okay, so this is NoSQL, right, MongoDB, this is NoSQL part. So SQL is different from NoSQL, and hence like you need to be strong in any one of the technology or any one of the databases in SQL as well as in NoSQL. Let's say in SQL you have MySQL, like you have BigQuery, and you have DB2, and obviously you have Oracle DB also, but that's again what do you call it? So again a commercial database. See, these are all commercial. Whenever you go to a cloud, AWS or Google or IBM or Oracle DB. So these are all nothing but your commercial databases, fine. And hence, like there is no real usage or other like real advantage you get, right? Just for the sake of so having good what do you call it? So good grasp over a commercial certificate, sorry, a commercial database as such. Okay. So because like once if I'm good in AWS and I'll in DynamoDB, let's say if I go to Google, I may fumble. Right? It may not really help. Okay. So they have different set of procedures. Okay. However, if you are good in open source like this, right, MySQL and MongoDB is not exactly open source, but yeah, you have free clusters. Okay. So here, these particular databases, particularly MySQL and MongoDB, these are actually like the most widely deployed databases in cloud. And hence, like, yeah, so try to be a master or be an expert in these two at least, okay, if not more. So that being said, so let's come to the shell scripts. Right. So the shell scripts is like, yes, so you need to have a good grasp over Linux commands. So why Linux commands? See, basically, like most of the times whenever we work, okay, particularly from data engineering point of view in production, we will not be using our on-premise data centers. Yeah, very rarely do we use on-premise data centers. In the sense, I will have my own server, I will have my own data center. Okay, I have my own server farm. Okay, I'll be maintaining it and then like working with my server only. So this gives a lot of privacy to my data. So that's really good. But the problem is the kind of money involved. So like setting up such an infrastructure. And hence people do move to cloud like AWS, Google, or IBM, which are like at least 70 to 80% cheaper than having an on-premise data center as such. Okay, so this is why how this is linked to Linux commands. So when you're going to AWS, Google, or IBM, or let's say you are good in, or if you are comfortable in Microsoft, fine, Microsoft Windows, and you want a Windows desktop over there, you cannot like deploy it for free. So it will cost you a lot. So because again, Microsoft itself, like so even the Windows local desktop application, obviously like you need to pay for it, and definitely you need to pay for their cloud OS also. However, when you're going with open source like Linux, obviously like you can deploy it for free. Yes, there will be a small deployment charge, but not the software application charge as such. And hence, like Linux, understanding Linux commands is very essential. That is one part of the story. And the other part of the story is like whenever you run the job, okay, so the different job, like, let's say like we call that as job. Okay. So or, like colloquially, I can say different tasks, different data management tasks and data manipulation tasks. So we'll be using a lot of Linux commands. Why Linux commands? What's the use of Linux commands? Let's say I have work orchestration tools. So here I have a user interface. So I can click the button and I can get the work done. And again, in ESP also, I can click the button. There is an application, click the button and get this done. SQL, no SQL, you have graphical user interfaces. Just at a click of the button, you can get like whatever you require. However, like what if I need to know shuffle between these? If I have to shuffle between, let's say, like this MySQL or MongoDB and then work orchestration, even streaming. So if I have to go back and forth, and if I have to do some operations which are hidden, let's say, like in many layers beneath in each and every GUI, so like it will be very tough for me, in fact. Okay, and hence to make things easier for us and for the system, for the computer, so we go with Linux commands. So you need to be good in Linux commands. And that being said, so once you're good in database and the Linux commands, okay, fine. Now that, yeah, you have the database set, you have all the data ready, let's say the 130 crore data, like, like 10 crore data, whatever, fine. And then you have, let's say shell scripts, fine. Then comes the work orchestration. So work orchestration in the sense, yes, you need to be doing some transformation. When we say transformation of data, so this is where like someone asked whether like the ETL is part of data engineering. Yes, ETL is a concept, right? So this concept is applicable over here. So here it is more extraction up to here. If you extract data from like the different sources and again like you store it in the database and get it ready for the next process. Now we are going to do some transformation. Transformation in the sense like I have to take only relevant data, right? So like in let's say like I'm collecting population data. Right? The population data can have many things. Let's say like I'm deploying my workforce who go door to door and then they get information on name, age, sex, religion, and let's say like whether they have whether they are in one house or rented house, whether they have a car or not. All this data they will collect. Okay. But let's say so having a car or not is not it's not going to be of any use to me. Let's say, right? So then I don't require that. So from the extraction layer, I need to get a transformation of like, or rather, I need to get only the relevant data which should be used, right? Which should be like passed on to the upstream processes, right? So this is possible only with work orchestration tools. So one of the beautiful work orchestration tool what we have is like Apache Airflow. This is an application, again open source Airflow. Okay. So you need to be good in this. So what it does is like it's a a scheduler. Let's say, fine. So it says like, okay, fine. So this is the chunk of data, and you need to do this transformation here. Once this is done, like you can store here or you can send it to the next level. Okay. Similarly, like next chunk of data will follow, and then it will. It's just a work scheduler. More like so post it or more like how you are maintaining a diary or like what to do today and what not to do. Right. So Apache workflow is like your personal diary, wherein like you will be maintaining a to-do list. Right. So now comes once this is done, we go with event streaming platforms. So one of the key application over here is Kafka. Apache again. So this is again open source. So all that we are discussing about now is like the open source, Apache Kafka. So here, event streaming platform. When we say event streaming platform, yeah. So in data engineering, yes, like we said, we have to use data engineering for two aspects, and one of them we have already discussed. That is big data. So when you have to handle big data, you have no other option than to like go ahead with all these processes. Okay, so that like or rather the data engineering process as such. However, there is another factor also. Okay, even though you don't have, let's say, you don't have big data or you have small data of some 10,000 rows or 20,000 rows, but you want real-time streaming of data, real-time streaming. In real-time streaming here, let's say, beautiful example is, let's say, Facebook, Twitter, or LinkedIn, or YouTube as such. So when you're pressing a like button, the like gets updated, right? And again, like it gets reflected in like, let's say, in the post very clearly, right? And whoever is like monitoring this post, so they will also get this data all within microseconds or millisecond latency. So that is a beautiful example of real-time streaming. Just imagine you give a like, and this like gets updated after 2 hours, and then it gets updated in the persons, that is whoever has posted, in his particular data engine, or in his advertisement column or analytics column, like after another 2 hours. So that's not going to be of any use to the user as well as for those who are posted, right? So even streaming, when we say there are two types of streaming, batch streaming, and we go with real-time streaming. So when you talk about batch streaming, so obviously as the name implies, so like you have batches of data ready to be processed. So like this can wait for, let's say, 2 hours to 20 days, let's say, for example. So 20 days once you'll be processing the data, 2 hours once you'll be processing the data. There is a strict time interval between one process and another process. Yes, like this interval can also be changed as per the business requirements. And again, you have real-time streaming situations. So in such cases, like only millisecond latency is the most preferred time frame, and hence like you need to work on that. So event streaming. So this is the function of event streaming platforms, and this being taken care by Apache Kafka. So after this, so Apache Airflow you have, and you have got Apache Kafka. So which means like the data is ready, and I got the relevant data, right? And again, I got the relevant stream. I have very good choice of stream also, right? Now on top of these three, all these things, you have something called Spark. Okay. So Apache Spark. Okay. So Apache Spark, what it does, if you are already familiar with pandas, Spark is nothing but what to say, a complicated pandas, nothing else. If you are not familiar with pandas as a library, like pandas is nothing but like a data manipulation library, so which is used to do data transformations, data loading, fine, and you can input the data and you can clean the data, all those stuff you can do. So using Apache Spark. Okay, similar stuff. Whatever you could do in pandas, you can definitely do in place of Apache Spark also. So once this is done, yes, so visualization engine. So here again, visualization engine, between visualization, okay, so I have the downloaded the data, uploaded the data, everything is fine. And again, like in Apache Spark, yes, okay, I'm doing the pandas, but where is the algorithm part? There was something called algorithm, right? So just hanging around, and there is no algorithm, and suddenly I'm jumping to visualization. Visualization in the sense I'm talking about dashboard. I'm not talking about your matplot or SNS kind of visualization. I'm talking about dashboards. Okay, the final dashboards which would bear all your insights, like business insights, okay, so reports, or again so your SWOT analysis or whatnot. So Apache Spark. From Apache Spark, actually Apache Spark has a YAML link. The sense, like it itself contains, Apache Spark itself contains a ML library, a library of like a set of algorithms, right? So once you process the data, so just imagine this is equivalent to pandas and scalar. So if I'm going to put both these together in a particular package, and if I'm going to give you, that is your Apache Spark over here. Fine. So Apache Spark, it has got its own ML library. Fine. So let's say for linear regression, for ALS, for extracting. So you can use this ML library and get the output. Fine. So they get the predictions out. And now once the predictions are out, obviously you can take to the dashboards. So yes, there are different types of dashboards. Okay, you have AWS, you have one type of dashboard. In Google, you have a data studio. Okay. So in AWS, obviously, I think it's blue. Okay, I need to have a check, but still, yeah. So you have blue there, and in Google, you have data studio. And apart from that, yes, you can even stream that to Tableau or Power BI. So all this can be done. So what has happened over here is actually this is the flow, and these are the different tools or the bare minimum tools we use in data engineering. Right? So from database to shell scripts to work orchestration to even streaming platforms to Spark to visualization or dashboards. Fine. So this is how things work. And okay, so this itself covers your data science job also, right? So if you could notice, it covers the data science job also. When you say data science job, we're talking about the algorithm knowledge. But again, then what is the role of a data scientist? So as I said earlier, here in this data engineering part, we'll be talking more on the how to tweak the data, how to ensure that the data runs faster into the system, how the data can be manipulated faster, how it can be transferred from one place to another easily, okay, and how to get it read or written very easily. Okay. So this is the whole objective. Okay. However, a data scientist, the objective of data scientist is to ensure you get the right predictions, right, or requisite predictions. Even though ML has algorithms, so you will definitely get some predictions, and but that predictions, if it is not right, let's say if it is not up to your expectations, obviously you need to change things. Right? That work is left to data scientists. So as I said, as I was telling from the beginning, so the role of data scientist is more of a researcher. However, that being said, so there is an overlap. Data scientists knowing a bit of data engineering and as well as data engineers knowing data science is again a very good, I would say even a lethal combination. So that always works good for the candidate. So so this is a very what to say. I have just scratched the surface of data engineering. Obviously, you could hope you could get the amount of complexity so that is involved in data engineering as such when compared to data science. Yes, data science is also equally complex, but from a kind of research point of view. So the objective there is to run the project and get the output and see how the predictions or accuracy can be improved. But in data engineering, even to run the project, you need the data, right? And that too, if you are going to work with heavy data, so heavy in the sense we are talking in terms of millions of data. So then obviously we have to do big data. So your small Python libraries, these guys cannot handle this. So obviously we need to come back to creating data pipelines with the other applications like what we have here, open source applications. So this is the surface, or I have just scratched the surface, and this is a brief about data engineering in ML, in running the ML project. Okay, how you can actually apply data science concepts, data engineering concepts to run an ML project. Okay. So hope people were able to understand. And again, now I stop for a while to take your questions, whatever it is, and whether it is from data science or from data engineering, still fine. Okay, so I can take your questions, and from there on we can, so we can decide the further course. So any questions? Okay, I think Apurva Gayan. Okay, so hope I'm pronouncing your name properly. Just a moment. Yeah, Apurva. You can unmute now.
Yes, sir.
Yeah, Apurva. Yeah, you have raised the hand. You have got questions.
Yeah.
Yeah. Yeah. What's your question? Okay. So Akshay Jadhav, which areas need coding and which does not need coding? Fantastic. So if you're going to see like, yeah, so you need coding knowledge, particularly, I won't say pure coding, but yes, some querying knowledge, query language, right? SQL is a query language. So that query language strength you require in this database area, fine. And again, like a bit of, again, the query language, again, in shell scripts, fine. So query language is very important. And this is like, so mix and match of like, few job executors here and there. So you don't really require coding over here. You don't require coding over here. And in Apache Spark and MLlib, yes, you require like a bit of coding. So in essence, like from end to end, if you see like 5 to 10% of the times it's coding is involved. Otherwise, like all that is involved is more of common sense and again like varying the strength, in fact, not just the coding strength. Okay. Yes, Siddhikar. Please wait. Yes,
Hello,
Siddhu.
hello,
Yeah.
sir. Am I audible?
Yeah, very much. Yes.
Okay. My question is, you listed in the database category that I need to learn SQL and NoSQL, and in the SQL category, you mentioned maybe some of relational database management software.
Right. Right.
But my question is it necessary to learn many database software? For example, as a database engineer, I have to learn Oracle, MySQL, or any other database software. So if I learn only one database software, relational software, for example, Oracle or MySQL, so is it enough to be a data engineer, or I need to learn all other relational database software?
Okay. Good question. So here I would suggest like you learn one database from SQL and one database from NoSQL. Okay. So that is more than enough. Okay. So particularly the open source databases like MySQL and again MongoDB. So that is more than enough. You cannot, or you need not, as well as you cannot learn like all the databases. So wherever the company, so wherever you go, let's say if you are in company A now, and again you are shifting to company B. Let's say the new company is using entirely new database, but SQL queries it is going to be almost similar everywhere. So if you know like in MySQL, if you are able to do things in MySQL, you will be able to do the similar stuff in PostgreSQL also. And again, if you are going to do PostgreSQL, so you already have the skill set to do the same work in SQLite also. Fine. So like almost like if you're expert in one database in each category, then definitely like you would be able to like handle other databases also. Almost 80 to 90% of query languages or other queries, it is going to be similar. Am I clear, Siddhikar? Am I clear, Siddhikar Rama?
Yeah. Yes. Yes.
Yeah.
Clear.
Yeah, good. Anyone else? Any questions? So how do you feel like this field as a data engineer? What do you guys think? Anyone? See, data engineering is more serious. Right? Let's understand that. Okay. And yes, like the more serious it is, the more complex it is. I would say like, the job market is very wide open for data engineers as much as to data scientists also. Because like there are not many skilled engineers like who could handle this data related issues very well. Right? So it is in the very nascent stages. And those who are getting in this stage now, like, yes, so they'll be able to reap benefits so much easier than compared to like people who are getting into data engineering after let's say some 2 or 3 years from here, because by then many people would have got this skill sets already. So understanding this flow itself will take you take one learner a lot of time. And again, like when you're spending a good amount of time and effort in each and every application, so someone whoever is going to compete with you, they also need to put so much of effort. So it's not easy for them. And hence the market is actually open and it is an expert job again. Right? So that part is there. Yeah, it's like magic, and when you do some process and get amazing results, and be surprised. Yes, obviously. But again, like there will be a lot of sweat and blood which goes into this. Okay, and not just that. Like when you're handling the so big a data, like crores or lakhs, right? So obviously, like understanding the insights from it, it's a tedious job. Yes, with the complexity, again to talk about the packages are really good, right? And again, like, yeah, so I think there was one attendee who asked about startup. Yeah, startup and freelancing opportunities are really tight. Okay. So, like, yeah, so all you need to do is put your heart into this. That's all. Good. Any more questions? Anyone would like to ask any question pertaining to data science or data engineering? Yes, Siddhi.
Okay, I have another one question.
Yeah, please ask.
Maybe I asked you twice. So
Yeah, no problem.
okay, and my question is, in the database section, you said many things that I learned, and I'm so excited to be that. But
Okay.
But I want to know that in the SQL languages, okay, and the specific question that I'm going to ask is, what's the necessity of Python languages, or is there any necessity in database to use the Python languages as a beginner? I want to know that.
Okay, fine. So, like, can I ask you a question if you permit?
Sorry?
Like, can I ask you a question if you permit? So, how strong you are in Python as such?
I understand. I'm almost sophomore. I can say I'm sophomore.
Oh, okay, fine. So, see, first let us be very clear. There is no Python involved anywhere in database or shell script or even in work orchestration or real-time streaming. Maybe yes, in Apache Spark, yes, like as you said, sophomore level Python, that's more than enough. So all you need to, as I said earlier, if you are good in list, if you are good in dictionary, you are so you are capable. You will be capable of handling such a flow very easily. Okay. So that's never a problem. Yes, Siddhika?
Okay, I understand. Thank you for
Yeah.
explaining clearly.
Yeah, thank you. So again, like one more thing, as since Siddhika asked, so Apache Spark. When we talk about Apache Spark, like Apache Spark can also be worked with Java. You don't require Python. Okay, let's say you are not good in Python and you want, but you are good in Java, right? So you can still work with Apache Spark, because Apache Spark, like surprisingly, it is not built on Python. It is actually built on Java. Java actually, it's not JavaScript, Java, right? And Java, and again, like there is one more language which is more machine-oriented language, which is Scala. We are good in Scala, okay. So not many of us have had hands-on in Scala. However, like if you're, yeah, so many of us would have started our career like whenever we started in software with Java. So if you know Java, Spark will be easy, no problem. Okay, Sharat Babu. So what is the procedure to get data? Okay, again, like the procedure to get data, it's not a technical one. That doesn't fall under the purview of data engineer or like a data scientist. So it falls under the purview of the business. So like you have to get data from like as per the business plan and business strategy from different sources. So again, so like, we really cannot, I really cannot comment on like where to get data, where not to get data. It changes, rather like, yeah, it differs from case to case. Just a moment. That's it.
Okay, I must forget to down my hand. Sorry.
Oh, okay, no problem. Okay, Akshay. So can you brief your journey from non-IT background to data field? Maybe computers, like how you started. Okay, like yeah. So just a brief, like so, like 10 years back, like I started as a freelancer, particularly as an Android developer. And then like, data is actually like when you are in non-IT field, particularly in mechanical engineering. So, you become a free, a data freak, in fact, right? So like a project management or quality. So obviously you run behind data only. Okay. So luckily from day one, so I was in this field like from the days of MS Access. So today you have different databases and different Python libraries. But if you ask me, I started from MS Access, using MS Access as if that is the glorious tool in the world, right? So, and again, yeah, we proceeded our journey, and there used to be a lot of demand for that. And yes, Oracle was also there in the really like, but again, Oracle was a commercial application, and we couldn't really spend much on that. And then, like, so I upskilled my skill sets, obviously. Like today, you have no courses like this, data science and data engineering. But again, in our days, let's say some 8 to 10 years back, we never had this. And but one thing we spend as such, like myself and whoever started during that time, we spend a lot of time in applied mathematics. Okay, so acquiring a lot of mathematics knowledge, particularly in statistics, matrices, and calculus, and probability as such. Okay, so that actually like resonates very well with us, strength what we have. Right? That's just a brief of like, how it started and how things go on. So it's all like you need to have a flair for software engineering, and again you need to be a data freak, entirely a data freak. So you need to look for data everywhere. Whenever you see data, you should have probing eyes, like what exactly it hides, and again, like, so what information I can get. Right? It should be more like an investigator. Right? So again, this naturally comes once you are like, non-IT background. Okay, so with the biased view, I would say in mechanical engineering, obviously, like you have a lot of opportunities to become a data freak. So yes, so that's how it happened. Actually. Okay. Yeah, good. So any more questions? Any more questions pertaining to data engineering where where that could be where you could build up a career or in data science as such? Okay. So like you guys do not have questions, then like, I think we have come to the end of the session. Fine. So if you have questions, I can wait and I can answer your questions. I don't have a problem. Okay, so otherwise, yes, we can wind off. And yeah, it's like hope like you guys got a good overview about what this data engineering is all about. Fine. So hope like I was able to like so kindle that spark in you, particularly for data engineering. And if that had happened, good for you actually. Fine. So so thanks for your patience and thanks for your presence so far. Right. So like